Direction cosines and direction ratio. That's the topic of this video. So before we go into understanding what is direction cosines, I want you to visualize the blue ball which is in this three-dimensional space. The object is going to rotate inside this three-dimensional space. You have like a cuboid and the object is placed almost in the middle of it. Just want you to visualize the location of this particular ball inside the three-dimensional space. Now, we're going to define an x, y, and z axis, and we're going to define this point O as origin. And let OP connect the origin to the ball, and let's define this ball as our point P in the three-dimensional space. And let's define this P as x, y, and z. Right. Now, what I'm going to do is I'm going to draw a line from P to the x-axis, which is perpendicular to the x-axis. I'm going to define this as my x-axis. So if I'm going to draw a line, so Px is now perpendicular to the x-axis. So can you start to visualize a triangle, which is a right angle triangle, O, X, and P? It's not flat on an XY or XY plane or XZ plane, but it's somewhere inside this three-dimensional space and it has its own plane. So this is the triangle that we're going to consider in calculating direction cosine. Now, I'm going to pull this triangle out, O, X, and P, and I'm going to place it here. So the base is OX, and the triangle has a hypotenuse which is OP, because it's a right angle triangle, and PX is the opposite side to this angle here. Right. Similarly, next let's draw a line from the y-axis. Let's define this as our y-axis, and draw a perpendicular from the y-axis to the point P. And now you can visualize a right angle triangle again, Y, O, and P. And let's start to place this triangle here. So you have the triangle OYP with OY as the axis, y-axis, and OP as the hypotenuse of the right angle triangle, and YP, which is the perpendicular from the y-axis to the point P. I hope this is getting clearer and clearer for you now. Next, let's pull out the third triangle, which is the perpendicular line from our z-axis. So we're going to define this as our z-axis and pull a perpendicular from this point here, from the z-axis to the point P. Great. So we have another triangle here which is O, Z, and P, and it's right angled at Z, right? So let's just bring that out here. So we have O, Z, and P. Great. Now I want you to see that all these triangles have angles, right? Maybe in my diagram, you're seeing all the angles as almost equal, but they may not be the same. They're all different triangles which we pull out from here. So what are these angles? If you take the first triangle, OP and X, this is my angle, and I'm going to call this angle as alpha. Similarly, I'm going to pull this angle, which is Y, O, and P, and I'm going to call this as angle beta. Okay, so you have angle beta here. Then we have the third angle, which is Z, O, and P, right? I hope you can visualize this, Z, O, and P, and this angle will be gamma. Okay, so we have our angles alpha, beta, and gamma. Once you have visualized these three triangles, now it's very easy to find the direction cosines. So To find the direction cosine, what you need to do is, let's consider our first triangle, which is O, P and X. Now we know that cos alpha would be adjacent side by the hypotenuse. So which would be this length here, which is X, by this length here. So we need to define this length. So let's define this length as, if we define OP vector as vector R and define it as xi cap plus yj cap plus zk cap, because we have x, y, z as its coordinate, then the magnitude of R can be defined as square root of x squared plus y squared plus z squared. Great. So now we have the magnitude of R as this, and it's this length here, which is OP. So I'm going to define this as magnitude of R. And we know that the adjacent side to angle alpha would be X. Or I can write here, this length is X. So what would our cos alpha be? Cos alpha will be X over magnitude of R. Great. So we have cos alpha here. Next, similarly, let's find cos beta. Cos beta will be defined as adjacent side of this triangle OYP over the hypotenuse of the triangle. So what is adjacent side of OYP? Adjacent side to angle beta would be OY, which is Y here, and OP will be again defined as magnitude of R. So we have cos beta as Y over magnitude of R. Similarly, from this triangle we can find cos gamma will be OZ, which will be Z, over OP, which is magnitude of R. So here we have cos alpha, cos beta and cos gamma. So these values, which is X by magnitude of R, Y by magnitude of R and Z by magnitude of R, are our direction cosines for the given vector OP. Now an interesting thing is, these direction cosines are unique. You cannot have 2 or 3 direction cosines for a given vector. The reason being, I can give you a more clear understanding of this. When you see these values X by R or magnitude of R, Y by magnitude of R and Z by magnitude of R, this would be actually a point on OP which would be somewhere here. It can be anywhere, but the length, the magnitude of that length, if X, Y, if this direction cosines point is somewhere here, then this magnitude would be a unit vector, which means it will be value 1. So basically direction cosines are finding the point which makes a unit vector which is parallel to our given vector OP. So I think that brings you to a very simple, clear understanding of direction cosines. So next, let's move on to see what is direction ratios. Direction ratios are related to the direction cosines. So in the direction cosine, we said we are finding the coordinate of a unit vector which is parallel to OP, and similarly in the direction ratios, we are finding the values which are proportionate to the direction cosines. So how can we do that? We have cos alpha, and we know that cos alpha was X by R magnitude. If we define cos alpha by X, then your answer would be 1 by magnitude of R. Similarly, if I'm going to divide cos beta with Y, then you would get that as 1 by magnitude of R. Similarly, cos gamma, if I divide it by Z, again you will get the value of as 1 by magnitude of R. So these values, which is x, y, and z, are proportionate to the direction cosines, because when you divide them, you get the same answer here. So we call x, y, and z as direction ratios. Now, direction ratios need not be unique. If I'm going to replace the x with a 2x, then what would I get here is divide this by 2x. Your answer would be 2 by magnitude of r. Similarly, if I divide cos beta with 2y, my answer would be 2 by magnitude of r. Similarly, if I divide cos gamma with a 2z, then again my answer would be 2 by magnitude of r. So now can you see that again by dividing cos alpha, cos beta by cos gamma with 2x, 2y and 2z, we get 2 by magnitude of r, 2 by magnitude of r and 2 by magnitude of r. So 2x, 2y and 2z now become our direction ratios. So direction ratios are not unique. If you want to geometrically understand what these direction ratio points are, these are the different points along this line OP. It's very significant to see that they are both called direction cosines and direction ratios. The word direction is specifically used. So it's all got to do with the direction in which OP is, and direction ratios are different points that you can have along this line OP, and direction cosine is a point on OP where from O to that point the length would be unit 1. Next, let's try and understand what happens if our theta is above 90 degrees. Okay, so what are the different cases of this theta? So let's assume that this is my x-axis, y-axis, and my z-axis. Okay, so I'm going to consider this as my positive side of the y-axis, and this is the positive side of the x-axis, and this is the positive side of the z-axis. So when I say that, the values here are 1, 2, 3 and so on, and the values here will be -1, -2, -3 and so on. Let's consider a point, say 2, 4 and 5. Okay, so which means my x coordinate here is value 2, and for y it will be value 4, and for z it will be value 5. Okay, so if I'm going to define this as a vector, let's call this point A and this as my origin. So then my vector OA can be defined as 2i cap plus 4j cap plus 5k cap, right? Similarly, let's consider a point here which is -3, 5 and 4. I'm assuming that the y and z axis are all positive in this, and only my x values are negative here, right? So let's find this angle. So, and its direction cosine will be cos alpha will be given as 2 over square root of 2 squared plus 4 squared plus 5 squared, and that will be equal to 2 over 4 plus 16 plus 25, and my value would be 2 over square root of 45. Similarly, I can find cos beta to be 4 by square root of 45, and my cos gamma would be 5 by square root of 45. Okay, now let's come to this coordinate. Let's call this as point B, and my vector OB can be defined as -3i cap plus 5j cap plus 4k cap. Okay, So what would be the cos alpha here? Cos alpha, the angle, so we have this as alpha. Let me call this as alpha 1. Okay, and this as alpha 2. So now my angle alpha 2 is this angle from the positive side of the x-axis to the vector. So this is my alpha 2. Now my alpha 2 is obviously over 90 degrees. So I'm going to call this, define this alpha 2 as cos pi minus alpha. So this is my angle alpha here. So this will be defined as pi minus alpha. And that is equal to minus cos alpha. So you can see that the value, if the value of the x coordinate is a negative value, your direction cosine will also be a negative number. So what is our OB vector magnitude? That's square root of 3 squared plus 5 squared plus 4 squared, and that would be equal to, that's equal to square root of 50. So my cos, or cos pi minus alpha would be minus cos alpha, and that would be minus, the value here is 3 over square root of 50. To make it more simple, you use this value minus 3 and divide it over the value of magnitude of OB, then you get your direction cosine. Similarly, our cos beta 2 will be 5 by square root of 50, and cos gamma 2 would be 4 by square root of 50. So our direction cosine for OB vector, for OA vector, direction cosines are 2 by root 45, 4 by root 45, and 5 by root 45. And my direction cosines for OB vector would be given by minus 3 by root 50, 5 by root 50, 4 by root 50. I hope this gives you a clear understanding of what is direction cosines and direction ratios. I hope you like this video, and if you have any questions on this, please feel free to post. I can further explain, making more videos on this. Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.